Hello and welcome to the ASC video series. My name is Dr. Sean Perry. This is Introduction to Statistics, STA 2023. We're looking at a problem from Chapter 2 on the empirical rule. So here we have the empirical rule as stated in the formula sheet. It says that for a normal distribution, about 68% of the data fall between the mean minus 1 standard deviation and the mean plus 1 standard deviation. About 95% of the data fall between plus and minus 2 standard deviations from the mean, and about 99.7% of the data fall between 3 standard deviations of the mean. Let's sketch the usual picture that goes along with this. So a normal distribution might have this bell shape. Its center is some mean. And given some standard deviation sigma, we might go up to the mean plus sigma and down by the same amount to mu minus sigma. And what the empirical rule is saying is that this area here is 68% approximately of the total area, or 0.68, given that the total area is 1 under any probability distribution. And now if we go one more step in each direction up to mu plus 2 standard deviations and mu minus 2 standard deviations, this area will be about 95%, or 0.95. Finally, if we go 3 standard deviations out above and below the mean, then this area constitutes 99.7%, or about 0.997 of the total area under the curve. Here we have a problem from Chapter 2. I believe this is number 26. The average SAT score is 1064 with a standard deviation of 180. The distribution of all SAT scores is known to be normally distributed. Use the empirical rule to address the following questions. Hint, sketch the distribution to help visualize the problem. All right, so let's begin with a sketch. They've given us an average, 1064. And they've given us a standard deviation, 180. And so if we were to draw a normal distribution, we would draw a little bell curve. And this bell curve is centered at 1064. And what we're going to be interested in is going up in some direction by 180. So this is our sigma, and this is our mean mu. And so what will we get if we go up and down by 180? So you can take out your calculator at this point and just add and subtract 180 to 1064. And we get the following: 884 up to 1244. Let's keep going. Let's do 2 standard deviations in each direction. So now we are adding and subtracting 2 times 180 to 1064 to get 704 and 1424 respectively. And then we go for 3. And so those two values are going to be 524 and 1604 respectively. So let's see, their first question is asking for 99.7% of the test scores lie between which two values? And we know that 99.7% lies between 3 standard deviations. So between 3 standard deviations, that's 524 and 1604. Now it says, if 700,000 students took the SAT, approximately how many students scored between 704 and 1424? So 704 and 1424, that's plus and minus 2 standard deviations. Okay, so 2 standard deviations, well, that's 95% of my data. So we expect that 95% or 0.95 of my total number of test takers, which is 700,000, will be between these two values. And we get 665,000. Very similarly, the last one, if 700,000 students took the SAT, approximately how many students scored between 884 and 1244? Well, 884 and 1244 are plus and minus 1 standard deviation. Your empirical rule says that 68% of your data, approximately, is within that range. So we take 68%, we multiply that by 700,000, and we get 476,000. Okay, I hope that's been helpful, and good luck with your studies.